realize that there is a tube like this, there is a tube like this, and there is velocity of the fluid emerging with Vv, etc. And when this fluid emerges from here with a velocity v, it exerts a reaction force rho a v squared this way. When this fluid emerges like this, it exerts a reaction force rho a v squared this way. Rho a v squared this way, right? Where v squared is 2g into h by 2. Realize that? It's because of height h by 2 that this velocity is there, velocity of a flux. So v squared is gh, right? Now, this force F and this force F constitute a couple. And the separation between these two forces, parallel forces of equal magnitude, is 4r. So, the torque of the couple is product of any one of the forces into separation between them. So, the required torque of the couple is like F into 4r. F into 4r is the torque of the couple, and the sense would be this way. When you look from top, it will be like this, clockwise, right? In AB, there is liquid of density rho, and in BC, there is liquid of density sigma. There is liquid of density sigma. This is the vertical radius r, and this is the radius at the interface. See, OB is the radius at the interface. So if this radius, and realize that AB is equal to BC, that's given in the problem, AB equal to BC. And if AC is the diameter, you realize that OB would have to be perpendicular to AC. OB would have to be perpendicular to AC, nahi kya? Because these two lengths are equal. This is equal, right? Now, if the radius makes an angle theta with the vertical, then with the horizontal, the diameter which is perpendicular to the radius, see this radius and this diameter, they are perpendicular to each other. So the diameter makes an angle theta with the horizontal, right? AC would make an angle theta with the horizontal, yes or no? Now, all that is important is that the pressure at the interface, right? This thickness can be neglected. The pressure at B because of sigma must be the same as pressure at B because of rho. That's why the interface would be here. If the pressure of the left was greater than the pressure to the right, it would move up. Otherwise, it would move down. Only because the pressure because of rho is the same as pressure because of sigma does this become the interface. Clear? So, the problem is now just ordinary geometry. The pressure at B because of rho. The pressure at B because of rho is rho g into the vertical separation between A and B. A is, right? AB is this. So, the vertical separation between A and B will determine the pressure at B because of this. The vertical separation between B and C will determine the pressure at B because of sigma. Okay. I'll just draw to avoid clutter. This is the horizontal. This is the vertical line. This is the diameter AC. This is the radius perpendicular to the diameter. This is B. This angle theta. This angle theta. This angle theta. Right? This is another horizontal passing through B. Another horizontal passing through B. This is a vertical. Okay. Now, AB, vertical separation between A and B. Is DE. Realize that the vertical separation between A and B is DE. So the pressure at B because of AB is rho G into DE. Would be rho G into DE, right? So rho G into DE. Now what's DE? This is R. This is O. What's DE? This length OE is what? R cos theta. Is R cos theta, right? R cos theta is this length. R cos theta. And from this triangle, this length OD is R sin theta. So OD is R sin theta. This is R cos theta. So DE would be R cos theta minus R sin theta would be DE. Yes or no? R cos theta is this length. This is R sin theta. So this would be rho G into R cos theta minus sin theta. That's the pressure at B because of the column AB, because of the column AB, right? Okay. Now, the pressure at B because of CB would be the vertical separation between C and B, would be the vertical separation between C and B, vertical separation between C and B. Let's say this is the horizontal through C. This is D prime. This angle is theta. This angle is also theta. Would be rho G into D prime E. Would be rho G into D prime E. Yes or no? I'm sorry, sigma. This is density sigma. So that's the same as sigma G into D prime E. ये D prime E क्या है? इतना ही तो ऊपर है. ये जितना नीचे था ये उतना ऊपर है. So this is like R. This is R sin theta. And this is R cos theta. See, this is R sin theta. And this is R cos theta. So R cos theta plus R sin theta. GR कट जाएगा. So you have like a cos theta into rho minus sigma is sin theta into sigma plus rho. So tan theta would be rho minus sigma by sigma plus rho, right? Aman, yahi kiya. So it was less physics and more geometry. I mean, there was no major rocket science involved, but there was just some ordinary trigonometry, right? सोचो कोई भी एक पिस्टन है, एनी वन. यहाँ पे फॉर एग्जाम्पल फोर्स वॉज F2. And the pressure here would have been F2 by A. Would have been F2 by A would have been the pressure, right? And now, when you apply a force F here, then this becomes F2 plus F by A. That becomes the pressure, right? That becomes the pressure. What's the increase in pressure? F by A. And for all of them, the increase in pressure is F by A for all of them. Then from Pascal's law, this is transmitted undiminished in all directions. That's Pascal's law. So the increase in pressure at any point would be F by A. The increase in pressure at any point would be. A block of iron kept at the bottom of a bucket of water. So This is water. And this is maintained at 2 degrees centigrade. The water exerts buoyant force on the block. The temperature of water is increased by 1 degree centigrade. The temperature of water is increased by 1 degree centigrade. The temperature of the iron block also increases by 1 degree centigrade. Okay. Now absolutely, if you've realized that from 0 to 4 degrees, there is anomalous expansion. So from 2 to 3 degrees centigrade, the volume decreases. The density increases. The density of water will increase up to 4 degrees. You know, it has maximum density at 4 degrees. That's anomalous expansion of water, right? So that's why this temperature is known to fool you. So from 2 to 3 degrees, density of water is increasing. The volume of iron is increasing. It's displacing more fluid. It's displacing more fluid. Not just it's displacing more volume of the fluid, even the density of the fluid is increasing. So the buoyant force is increasing, more volume of the fluid displaced, and that too at higher density, right? So originally, if it was displacing V naught, now it's displacing V naught plus V volume of water, because iska bhi to volume badega, right? And more volume of water at higher density. So that means more weight of water is being displaced, and more weight of water means greater buoyant force. Chalo, you identified that. Anyone else who got this right? Oh, very good. You identified its anomalous expansion? Very good. Good. An open tank 10 meters long and 2 meters deep is filled up to 1.5 meters of height with oil of specific gravity 0.82. Oil of specific gravity 0.82. The tank is uniformly accelerated along its length from rest to a speed of 20 meters per second horizontally. The shortest time in which the speed may be attained without spilling any oil, means 0.5. That means this point would come eventually here, all the way up to 2 meters. If you don't want oil to be spilled, this is how it will be. 10 meters. This is what you want, where this is the acceleration, this angle is theta, where tan theta would be A by G, tan theta would be A by G. Now, realize that if this length is x, then the area of this must be the same as area of this, because the same volume depth is the same, right? So area of this rectangle is like 1.5 into 10. That's the area of this. That must be the area of this trapezium. That is 2 plus x average of parallel sides into distance between them. So that makes it 3x is 1 meter. X is 1 meter, right? You समझे क्यों किया? This x is 1 meter means this is 1 meter. This is 10 meters. So tan theta would be 1 by 10. Tan theta would be 1 divided by 10. A is therefore 1 meter per second square. So the required time in which 20 meters per second is reached is like 20 divided by 1, that is 20 seconds. That's the shortest time. अगर इससे कम टाइम में करोगे तो एक्सेलरेशन वुड बी लार्जर देन दिस, एंड व्हेन द एक्सेलरेशन बिकम्स लार्जर देन दिस, थीटा वुड बिकम लार्जर एंड इट विल स्पिल ओवर. So you can't have a value of acceleration greater than this. So this is the largest possible acceleration. This must be the shortest possible time. है ना? This must be the shortest possible. ठीक है? Now these are two liquids. One of them is density 2 rho, the other one is density rho. Which one must be 2 rho? Left or right? This is one liquid, this is another liquid. एक का density rho है, the other one has density 2 rho. Which of the two must be density 2 rho? Huh? This one must be 2 rho. No, this one must be 2 rho. Reason being, सोचो इसका फ्री बॉडी डायग्राम सोचो इस पूरे लिक्विड कॉलम का, ठीक है, इस लिक्विड कॉलम का नीचे वाले का, ठीक है, दिस इज L/2 L/2. हाँ, this has an acceleration A. ठीक है, that means pressure here must be higher than the pressure here, same height. So यहां पे प्रेशर ज्यादा होना चाहिए था ना, so that they would have been a net force to the right, same height के लिए the pressure here would have been higher. If the density of this was higher than this, so this must have been 2 rho, this must have been rho, you know, this must have been 2 rho, this must have been rho. Clear? Now the difference in pressure, what does it do? The difference in pressure between these two gives this mass an acceleration A to the right. ठीक है ना? यहां पर pressure is 2 rho GH, यहां पर pressure is rho GH, right? The net force acting to the right is difference in pressures into area of cross section A of this, area of cross section A of this lower tube. So difference in pressures 2 rho GH minus rho GH into A. That's a net force acting to the right. That must be equal to mass of this column into acceleration of this column. Mass of this column is mass of this column plus mass of this column. This column is 2 rho, this column is rho. Mass of this column is 2 rho A into L/2, right? A into L/2 is the volume into density. Mass of this column would be rho A L/2, right? Rho A volume, I'm sorry, A into L/2 volume into density, right? This into acceleration A, this into acceleration A. Or we have rho GH equal to A into L/2 into 3 rho into acceleration A. A cut गया. L/2 into 3 rho into A. That's rho GH. So then you have the, क्या निकालना क्या इसमें? Height निकाल लो. Height is 3/2. ठीक है? How many of you got this right? How many of you got this right? Others made a mistake. What kind of mistake? बहुत ज्यादा सोचे ना इस प्रॉब्लम के बारे में, वही गलती हो गया. एक तो you made a mistake in figuring out कौन सा रो है कौन सा 2 रो है, तो पहले उसके बाद तो सभी पाप रहता इस पाप के बाद. But was there anyone who started with 2 row and row? No. मास का कर दिया बस, रुक गई सभी की सांस. होता है ना, actually everything is very simple. Sometimes just because it looks little different, your approach becomes indifferent. But I mean, almost towards the end of this journey, which might have had different flavors, different colors, you may have got intimidated by things. There must have been things that may have looked very fluid to you. It's very simple. But if you really grip the totality of the situation, nothing was esoteric, nothing was exotic. Things are pretty much within reach. A problem which looks kind of outlandish to begin with, eventually when you sit down with a very plain sense of thinking, it boils down to something very straightforward, something very fundamental, nothing difficult, very ordinary, simple looking concepts. You may have learned like bizarre formulas, bizarre results, may have done 100 different things, but you can put all that aside. Just think fundamentally. Everything would be within reach. Don't have to think bizarre. Don't have to expect bizarre things. Simple thinking, downright first principles, and that will work in most cases. In certain cases where, let's say, it's a little more sophisticated than that, if you can't do that, it will not make a difference. But the bulk of the question paper is all simple stuff. If you crack the simple stuff right, you get a very high rank. Important thing in your question paper, identify speed breakers, things that you should not be doing. You should have an eye for speed breakers. There are sitters. Sitters make the difference. People who don't get through IIT are those who are not able to crack these sitters. The very simple stuff. And then there are intermediate problems between sitters and speed breakers, more closely related to sitters, but slightly more than that. That builds the rank. But then again, even if you have cracked all the sitters right without a mistake, and have cracked a few between sitters and speed breakers, then you get a very high rank. If you are not able to crack a problem which looks bizarre on the face of it, not an issue. Not an issue. It will not make any difference. Most people get so much pressurized in an exam like IIT, and despite their preparation, they lose their nerve. They lose their sense of composure. And that is where they buckle to the pressure. If you don't buckle to the pressure at the time of the exam, if you don't think of the exam, just think of what you're doing with some semblance of excitement about being able to do things right one after the other, not bothering about what the outcome would be, then your performance would be at its peak. Otherwise, if the thought about the exam results, the thought related to what's going to happen, I've worked so hard, I have done this, I have done that, if that overpowers you, if you're within control of such an emotion, that's where you lose the game. So, to be able to win this game, not too much, but too little, clubbed with too much of composure. That's really the mantra. I mean, if you've done your basic job right, if you know your concepts right, then you don't have to worry too much about things. Alright, let's look at the next problem. So, this contains fluid. These cylinders have an acceleration A. These cylinders have an acceleration A. And this tube is not slipping on these cylinders, is not slipping on these cylinders. So if you really look at these cylinders, and if there is slipping nowhere, and if this is A, what must be the acceleration? Absolutely, acceleration of the topmost point is 2A, right? And therefore, the acceleration of the tube is 2A rightwards. Acceleration of the tube is 2A rightwards. Take it. If the tube was fixed, then water would spurt at root 2 GH, would spurt at root 2 GH. But if the tube itself is moving, the water would remain confined in the tube. It will not spill over, right? So this has a velocity root 2 gh coming out. But if the tube itself has moved, it will again house the water that is attempting to get ejected. Realize that? Important thing here is that the acceleration of the liquid column here, if that's the same as the acceleration of the tube, it will not spill over. You know what I'm saying? If the acceleration of the liquid column inside is the same as the acceleration of the tube, then it's not going to spill over. You know? Because then from instant to instant, the velocity of the tube will match the velocity of the water attempting to spurt out. So it will completely house the water. From instant to instant. There would be no observable spilling over. Are you there with me on this? है ना? यही तो होगा. So then if this is the concept and as simple as this, then look at this column of the liquid. I know this tube has an acceleration 2a. Now look at the liquid alone. The liquid alone must have an acceleration 2a rightward. Liquid alone must have an acceleration 2a rightward. Now just look at the liquid column. This is A, this is B. What's the difference in pressures between A and B? Huh? कितना है? Rho GH नहीं, because see the pressure is rho GH plus atmosphere here and atmosphere here. So the difference in pressures is rho GH. Okay. So the net force here, F net, is like rho GH into area of cross section A. This is the area of cross section. That's a net force acting on the liquid column. That must be equal to mass of the liquid column into acceleration. Acceleration liquid column का क्या होगा? 2a, right? So mass of the liquid column is A into L is the volume into density into acceleration. Acceleration 2a, sorry. Acceleration 2. उसे A आ जाएगा. You get A. Is it not? कोई confusion है? नहीं. Non-uniform cylinder of mass m, length L. Whatever, small l. Radius r and having its center of mass at a distance L by 4 from the center. This is the geometrical center. And the center of mass is here. The separation between the geometrical center and the center of mass is L by 4. The moment of inertia of the rod about the center of mass is I. The angular acceleration of the point A relative to B. I mean, it's the same. The angular acceleration, it does not matter. I've given you this concept. I've told you, don't get needlessly restrictive about the angular acceleration. The concept is not about one with respect to another one. All that you need to do here is realize that the center of mass of the displaced fluid would be at C. Right? Would be at the geometrical center of the displaced fluid. The displaced fluid is uniform only. So this is the displaced fluid. The center of mass of the displaced fluid is this. This is the center of mass of the cylinder. Right? Now, through this, what acts? The weight of the cylinder. Through the center of mass of the displaced fluid, what acts? Buoyant force upwards. Buoyant force is what? Volume of water displaced into density into G. That would be the buoyant force, weight of fluid displaced. So then, let me take torque about this point. So then FB into L by 4, that's a net torque about the center of mass. That must be I about the center of mass into angular acceleration alpha. FB पता है? FB is weight of the fluid displaced. So pi r squared L into rho into G into L by 4. That's IR, etc.